In this video, we're going to have a look at the intersection of sets. So let's start with our definition. We're going to start with two sets. So let S and T be sets. Okay, so I have two sets. Now the intersection of S and T, which is denoted by, we're going to have some notation here, denoted by S and the little cap symbol here, S intersection T, is the set whose elements belong simultaneously. This is a longer word than I want to write on the tablet, but simultaneously to S and to T. Okay, so let's have a look at what the intersection means. The intersection of S and T is the set whose elements belong simultaneously to S and T. What does that mean in terms of Venn diagrams? So I have two sets like this. I have S and T. Now the intersection is this part right here. So the keyword here is and for the union of two sets, the keyword is or. This is how you're going to differentiate those two concepts. So I'm going to give you the trivial examples, meaning as the most obvious examples I can think of. So let S be a set. So this is our first example. The empty set intersection S is equal to the empty set because for any set S, well, it doesn't have any elements in common with the empty set, so its intersection with the empty set is, well, the empty set. Now, if you take the intersection of S and itself, it's going to give you set in question. For some non-trivial examples, I can, I think it's fairly straightforward. If I have 1, 2, 3, 4, intersection, let's say 2, 3, 4, and 5. Well, 2 and 3 are in both sets, so they're going to be part of our intersection. Actually, 4 is also in both sets. Let's add it here. 1 and 5 are not in both sets, so we're going to omit them. If we wanted to add them in our Venn diagram, we could have 1, and then 2, 3, and 4, and 5 would be in T. Another example, let's say I have 1 and 2, intersection 3 and 4. Well, I don't have any, there are no common elements in those two sets, so it's simply the empty set. And in this case, we say that the two sets are disjoint. So whenever I mean that two sets are disjoint, well, I simply mean that their intersection is the empty set. Now we like to think of the intersection of two sets, let's say S and T, as the largest subset of T, of S, which is also a subset of T. Okay, so this is something that you can take some time to ponder. And let's briefly recall the definition. We have two sets S and T. The intersection of S and T is the set whose elements belong simultaneously to S and to T. And that's it for this video.